Hello, my name is Ken Wachtel. This is for Digital Systems Experiment 10, Muxes and Demuxes. In this circuit, we have a 74 ALS 151 chip, which is our 8-input mux. We have our 74 ALS 138 Demux chip, and we also have a 7476 chip, which is basically our flip-flop. We have it connected into both these chips as a mod 4. The output of each flip-flop are connected to LED 0 and LED 1, where 1 is the most significant bit. For our 8-input mux, we have I0 with switch 0, I1 with switch 1, I2 with switch 2, and I3 with switch 3. The output of our mux comes from the inverted output of Z, which is then connected to the inverted E1 of our Demux. The inverted Z output is shown by LED 3, and the output of our Demux comes from O0, which is LED 4, O1, which is LED 5, O2, which is LED 6, and O3, which is LED 7, where 7 is the highest. So when our mod 4 counter is at 0, 0, the output of the inverted output of Z is at 1, and O0, O1, O2, and O3 are all at 1. So we'll toggle the clock. So when our flip-flop is in the state of 0, 1, our Z output is at 0, O0 is at 1, O1 is at 0, O2 is at 1, and O3 is at 1. We'll toggle the clock again. So we are on our third state at 1, 0. Our Z output is at 0. Our O0 output is at 1. O1 is at 1. O2 is at 0. And O3 is at 1. We'll toggle the clock again. In our last state of our mod 4, where it's 1, 1, our Z output is at 1. O0 is at 1. O1 is at 1. O2 is at 1. And O3 is at 1. So I'll go through it one more time. At 0, they're all on. At the state 2, which is 1, 0, or 0, 1, as 0 being the most significant, our Z is at 0, and O1's at 0. Third state, Z is at 0, and O2 is at 0. And our last state, they're all at 1.